Good morning. In this video, I am going to show how to conduct various unit root tests of all the variables at the same time in Eviews. You might have seen how to check stationarity or unit root of a single variable in different softwares, but in this video, I am going to show how to perform unit root tests for all the variables at the same time, and I am using Eviews software for this purpose. So let me start with some example here. I have data on 4 variables, and here I am showing the graphs of 4 time series at a glance. This is the graph of GDP, and if you see, it has a upward trend. Similarly, personal consumption expenditure also exhibits like GDP, and it has a positive trend, upward trend. This is investment. There are some fluctuations, but there is overall positive trend of the investment expenditure. And finally, this is the graph of government expenditure, and of course, just like GDP and personal consumption expenditure, the graph of government expenditure also has a positive trend. Here I am showing in this slide all the unit roots of the 4 variable, that is GDP, personal consumption expenditure, investment, and government expenditure. And here I am using ADF test. These are the test values at level, and these are the test values at the first difference. Similarly, on the right we have PP unit root test for all the 4 variables, that is GDP, personal consumption expenditure, investment, and government expenditure. The upper one is at level, and this one is for the first difference. I will discuss this later on, but first I would like to show how can we do that in Eviews. So let me close this, and let me close all these windows, and I will delete this group. So this is my file, and I have various variables. This is government expenditure, this is gross domestic product, this is investment expenditure, and this is personal consumption expenditure. This is monthly data from 1980 to 2012, and there are 129 observations. So let me show you the series first. You see, this is the third month of this is March 1980, and this data goes all the way through March 2012. So there are 129 observations for this data. So let me close this, and I would like to open these variables as a group: personal consumption expenditure, investment, and government expenditure, and open as a group. So this is there are 4 time series: GDP, personal consumption expenditure, investment expenditure, and government expenditure. And if you scroll down, there is no missing value. So we have observation on all these variables. There is no missing value. So there are 4 time series. So how to conduct various tests, that is ADF and Phillips-Perron and others, at the same time for all the 4 variables. So I have to click on adds in, and if it is not installed already, then you will have to click on add in, and then you will go to manage manage adds in, and you will have to install URL, that is unit root all. Since I have already installed it in my Eviews, so I will click on all unit root tests. So after that I will write name of the variable. So I have GDP, personal consumption expenditure, investment, and G, and here I have an option. So I can use ADF, PP, KPSS, or ADF and PP. So let me stay with ADF, and here I can also um, select either Schwarz information criteria or Ekaike information criteria. So let me stay with the SIC, and now I will press OK. So here is my result. Let me make it a little bit smaller. So I will come here, and you see uh, here it says unit root test results table ADF. So I'm using ADF test for this. The null hypothesis is that the variable has a unit root, that is it is non-stationary, and I'm going to test this null hypothesis. Now in this half of the table we have three different scenario: with constant and trend, without constant and trend, and there are four variables. So if we look at GDP, we fail to reject the null hypothesis of no unit root test of a unit root test. With constant, we also fail to reject this hypothesis with constant and trend because the p-value is greater than 0.05, and similarly without constant and trend we also fail to reject this null hypothesis. Coming to personal consumption expenditure, with constant we fail to reject, with constant and trend we also fail to reject the null hypothesis, and without constant and trend we fail to reject this hypothesis, this null hypothesis. Similarly, we also have the same story for investment and government expenditure. Since all these p values are greater than 0.05, so we fail to reject the null hypothesis that the variable has unit roots. So it means that at level all these series are non-stationary and they have a unit root test. In this part of the table, we take the first difference, and there are t-statistic and probabilities, and for all the four variables, with first difference, for all the three scenarios, with constant, with constant and trend, and without constant and trend, we strongly reject the null hypothesis that the series have unit root. So at the first difference level, these series become stationary with constant and trend, and without constant and trend, and you can guess from the stars that are given here. So we strongly reject here, we strongly reject here, we strongly reject here the null hypothesis. Here we fail to reject this hypothesis at 5%, but at 10% we reject the null hypothesis. Again, for with constant and trend, for all the four variables, we strongly reject the null hypothesis of a unit root, and similarly for without constant and trend, for GDP and investment we strongly reject. For personal consumption expenditure we reject the null hypothesis at 10%, but we fail to reject at 5 and 1% level, and for the government expenditure we reject the null hypothesis at 5% level. We can also do the same for Phillips-Perron test, and I will go here again to all unit roots, and this time I will check PP, and I will write GDP, personal consumption expenditure, investment, and government expenditure, and clicking OK, I get this table, and it says unit root test results table Phillips-Perron. So again, when I compare these results with the previous test ADF, all the variables all the variables with constant, and trend, without constant and trend have p-values which are greater than 0.05. So it means that all these four variables for the three different scenarios have unit roots and they are non-stationary at the level, and I'm using Phillips-Perron test. But when I take the first difference, all the four variables become stationary for all the three scenarios, that is with constant at the first difference, the GDP, the personal consumption expenditure, the investment and the government expenditure, we strongly reject the null hypothesis that the variables have a unit root. So when we take the first difference and with constant, the GDP, PCE, personal consumption expenditure, investment and government expenditure, they become stationary. Similarly, for with constant and trend, all the four variables become stationary, and we strongly reject the null hypothesis that the variables have a unit root at 1% level. But if we come to without constant and trend, the result is the same, that all the variables are now stationary, and based on the p-values, we strongly reject the null hypothesis of unit roots for all the variables. Now this is very interesting, ladies and gentlemen. Here I am comparing both the ADF and the PP, and the results are almost the same. There is no difference, but this is how we can check unit roots for all the variables at the same time in Eviews. So ladies and gentlemen, I hope this was quite helpful and informative for you. If you like the video, kindly subscribe to the video and click on the bell icon, share it with other friends so that they can also get benefit of the video.